Hi guys, this video is revisiting inverses, but now we're going to find the inverses of exponential and logs, which we already know how to do. It's just a different application. Instead of solving this equation and getting a final answer, we're rearranging it and getting a new equation. That's the inverse. So if you remember, like when we first heard the word log, we went over why these are inverses of each other. The x and the y's, the ordered pairs are different, their key features are opposite, but this is the way we do it. So I am going to organize my steps with a do-undo list, the same way that we did the first time around. So a do-undo list, we identify the order of operations. Please excuse my dear Aunt Sally. So I do actually have parentheses around the x plus 3 that's in my exponent. We don't draw the parentheses there because you can tell the whole thing is an exponent. So there are in like an invisible set of parentheses around there. So parentheses would be the first thing I did. Please excuse my dear Aunt Sally, right? So I have a plus 3 as the first thing I would do. All right, so I also have an exponent. That itself is an exponent. So I have a base and a power. So I'm just going to write that down as an exponent step. I have 2 to the power of something. I don't have any multiplication or division, but I do have subtraction. So the opposite of all of those are the undo list. So the opposite of minus 4 is plus 4. And the opposite of having a base of 2 is having a log with a base of 2. And so I'm intentionally leaving that set of parentheses blank because as I'm working this out, I will have something to put in there. But for right now, this is just how I organize what I'm going to do, so that parentheses is blank for now. And the opposite of plus 3 is minus 3. All right, so we follow the list from the bottom to the top. So I have an idea of what steps I should be taking when I solve this equation. So some of the classwork that we do, it doesn't have a do-undo list on there. It just kind of works it out step by step. So I'm going to work it out step by step, but I'm using my undo list. All right, so if I'm working this out, the first step is to swap the x and the y. Just swap the x and the y. And so you can see from here, after you swap the x and the y is when you start following what's on your undo list. So I'm going to add 4 to both sides. So keep in mind, I do not have any like terms. I'm not making this equation any smaller. I'm just rearranging it, doing the opposite, and my goal is to move these things away from the y. And following my undo list is moving things away from the y. So when I add 4 to the left, I'm not combining it with anything. It's just now going to say x plus 4. And the minus 4 is gone, because adding 4 to both sides would cancel the minus 4, and now the left-hand side just says x plus 4, because I added 4, but there's nothing to combine it with. All right, from here, I'm going to do my log. So log with a base of 2, the x plus 4 is what's going to go on the inside. So log with a base of 2, the x plus 4 is what's going inside, and this side still says y plus 3. But the 2 that was on the right is gone. That step takes the y plus 3 and brings it down. All right, and then from here, minus 3 on both sides. So when I minus 3, that's just going to be everything that I had from the previous step minus 3. So basically, each new step is everything from the previous step and then whatever the new thing that you're doing is. And so we just flop it around so that it's y equals. That is my inverse equation. All right, so let's do a few more. Remember that you can pause the video, and when you come to class, if you have questions about it, you should ask. So here's one that starts off as a log. All right, and again, I'm going to organize what I'm doing with a do-undo list following, please excuse my dear Aunt Sally. So parentheses, I do have something in parentheses, but I mean, it's just x, so that's not an operation. The log is going to count as an exponent step because the log and the exponential are inverses of each other. And so if my log is a base of 6, the thing that undoes that is 6 to a power. So log with a base of 6, if I want to undo it, I'm going to need the exponential form to have a base of 6. And again, I'm leaving that blank because I'm going to have something in there. I just don't know what it is yet. All right, I do have multiplication. So the opposite of multiply by -2 is divide by -2. You notice that it's still -2 because the operation is multiplication. So instead of multiplying by -2, I need to divide by -2. And I do have a subtraction step. So the opposite of -5 is +5. All right, so again, I'm following the list from the bottom up. All right, so when I go to work it out, I'm going to be using my undo list to help remind me of what I'm supposed to be doing. So I am going to swap my x and my y. All right, oh, I always forget to do this. I always forget to actually make this one y. All right, so the first step is to add 5. So it's going to be gone from the right, and now the new left is going to say just x plus 5. But the -5 is gone. I add it over to the other side. All right, now I am going to divide everything by -2. So that's going to cancel the -2 that's in front of the log. All right, and my next step is to have a base of 6, and everything that I wrote is my new exponent. Because remember, each step, it builds on what you had previously. So this next step, I need a base of 6, and my exponent is going to be the entire mess that I have there right now. And that is my inverse equation. I'm just going to flop it around. But that is my inverse equation. All right, let's do another one. All right, so my do-undo list. I do have stuff in parentheses, and I actually have quite a bit in parentheses. So I'm going to have to break this down because I have more than one operation inside of the parentheses. So within the parentheses, I have multiplication, and I also have addition. So multiplication would go first. So multiply by 2 is first, and then I would tackle the +3. All right, and then I do have an exponent step because I have a log. So log and exponents, they kind of go together in the same step. So ln, so the opposite of ln, remember, is e with whatever exponent I need to have. And then I do have a multiply. So multiply by 10, divide by 10. So I had parentheses, exponents, multiplications. So now I'm going to start. All right, so I am going to swap. Oh, I forgot to put the y equals. But pretend that said y equals. So it would now say x equals 10 ln 2y plus 3. The first thing I'm going to do is divide by 10. So my left is going to now say x over 10, and that's gone. All right, my next step is to do the exponent. So I need a base of e, and the x over 10, that was already there. So now ln is gone. So now it's just 2y plus 3. All right, I'm going to subtract 3. I'm going to divide everything by 2. I'm running out of room here, so I'm just going to do that. All right, so my new equation, e to the x over 10 minus 3 divided by 2. It doesn't have to look pretty, just has to look opposite from the way that it started. All right, let's do one more. All right, so in this case, I don't have any parentheses because my exponent is just x. I do have an exponent, so 3 to the power of x means I need log with a base of 3 to cancel that out. I do have multiplication, so times 2, divide by 2, and I do also have addition, so plus 4, minus 4. So exponents, multiply, and addition. All right, so I'm going to swap the x and the y. All right, my first step is subtract 4. So now this side is going to look like x minus 4. And the 4 from the right-hand side is gone. I'm going to divide by 2. So now the 2 is gone. And I'm going to convert this to a log. So my base is 3. And everything inside the log is what I had already written. All right, flip it around to make it nice.